Hi everyone, this is Dr. G. Ravindranath Reddy working as Assistant Professor of Mathematics in MLR Institute of Technology, Hyderabad. So we are discussing the numerical methods and integral transform course. So in that course we are at the point of divergence of a vector point function. So now in this video we will discuss how to find out the divergence of the given vector point function. So for example, suppose I have given a vector point function and at some situation I want to convert this vector point function into a scalar. Then how can you convert this? In order to convert that vector point function into a scalar point function, we are going to use the concept of divergence here. So now we will take how to find out the divergence of a vector point function. So now I have taken a vector f bar is equal to f1 I bar plus f2 z bar plus f3 k bar. This is the vector I have given. Now I want to convert this vector into a scalar. So whenever we want to convert into a vector as a scalar, so then we have to go for the divergence of f bar. Divergence of f bar, which is represented with del dot f bar. So we know what is del operator, how to represent this del operator here. So this is the del operator, I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z into f bar. So f bar is given by f1 I bar plus f2 j bar plus f3 k bar. So whenever we know, just now in the previous videos we have seen how to apply the dot product between the two vectors. So just you take the coefficients of I bar from both vectors and multiply that. The coefficient of I bar in the del operator is dou by dou x, and whereas in the f bar in the given vector the coefficient of I bar is f1. So this can be written as dou f1 by dou x. Plus similarly take the second j bar coefficient and in the vector j bar coefficient, that is dou f2 by dou y plus dou f3 by dou z. So now after applying the dot product between the two vectors, then the resultant value is always a scalar. So that is given by dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So this we can consider as the divergence of the scale vector point function. Okay, so now whenever this div f bar value is equal to 0, whenever we get that div f bar value is equal to 0, then whatever the vector we have considered, that vector we can consider as we can say that vector is a solenoidal vector. So vector point function f bar is said to be solenoidal if that div f bar value is equal to 0. Whenever this div f bar value is equal to 0, then we can say that the given vector is a solenoidal vector. So now these are the two definitions we have to consider. One is finding the divergence of a vector point function, and how can you say that the given vector is a solenoidal. So now on these two concepts we will take some problems here. So this is the problem. So I have given a vector point function, and for this we have to go for the divergence at that particular point. So divergence, we just now have seen how to find out the divergence of the vector. So now you consider this vector as f bar. So now once if you consider this f bar as this one, the standard form is f1 I bar plus f2 z bar plus f3 k bar. Just find out f1 value here. So f1 is equal to, you will get xy square, and f2 is equal to 2x square yz, and f3 is equal to minus 3yz square. Now just find out the partial derivative of f1 with respect to x, f2 with respect to y, f3 with respect to z. We can get our divergence value here. So div f bar is given by dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. You find out these values here. So you will get y square plus 2x square z minus 6yz. But here in the problem he has given the particular point. At that point, for this vector we have to find out the divergence here. So substitute that point here. So this is x comma y comma z. This is of the form x comma y comma z. In place of x, take x is equal to 1. In place of y, take y is equal to minus 1. In place of z, take x is z equal to 1. So if you substitute this, you will get our scalar value here, that is 9. So once if you observe here, in the beginning he has given a vector point function. After applying the divergence concept here, then finally it is converted into a scalar point function. So this is the way how we can convert that vector into a scalar point function. Suppose if you have given any point, you substitute that point, you will get some constant value here. So next, find do f bar. So where f bar is equal to, this is the value. So first, in order to get that f bar value, first we have to apply the gradient for this scalar point function. So whatever the, after applying the gradient for the scalar point function, you will get some vector. You take that vector, and for that vector you find out the divergence here. That is the meaning of this problem. So whatever the scalar point function he has given, I will represent that scalar point function as pi. Now for this pi, you apply the gradient. In the previous videos we have seen how to find out the gradient of a scalar point function. Okay, so now gradient pi, del pi is equal to I bar into dou pi by dou x plus j bar into dou pi by dou y plus k bar into dou pi by dou z. For this you apply the partial derivative with respect to x, with respect to y, with respect to z, and then substitute these values here. So gradient pi is equal to, so we know, I already discussed how to find out the partial derivatives here with respect to x, y, z. So this is our del pi value here. So now you consider this del pi as f bar, and for this f bar we have to find out the divergence here. So let f bar is equal to, this is our f bar value what we got for gradient pi. So now you find out divergence of this by using this formula. We can get our required value here. So 6x plus 6y plus 6z. So after taking 6 outside, we will get 6 of x plus y plus z. So this is the way how we can find out this divergence here. And now, so now we'll go for the second concept, that is a solenoidal vector. We have taken the definition. So d f bar value is equal to 0, then we can say that that vector is a solenoidal vector. So now already he has mentioned that whatever the vector he has given, that vector is a solenoidal. So by using this condition, so in this vector we can find some unknown parameter here p. Now our task is we have to find out that unknown parameter p here. So in order to find out this unknown parameter, he has given that whatever the vector he has given, that vector is a solenoidal vector. So how can you say that the vector is solenoidal? If do f bar is equal to, do f bar is equal to 0. Now by using this condition, we have to get the value of pi here. So now take this f bar value, find out do f bar, that is del dot f bar. This do f bar is also represented with del dot f bar. So now find out that del dot f bar value. You will get this del f bar is equal to 2 plus p. So now use the condition. Do f bar is equal to 0. Why you are considering that do f bar is equal to 0? Because in the problem he has mentioned that whatever the vector he has given, that vector is a solenoidal. Solenoidal, how can you say that the vector is solenoidal? If that vector satisfies this condition. So do f bar is equal to 0. What is the value of d f bar? We got 2 plus p is equal to 0. So from this we can get p is equal to minus 2. So this is the way we have to find out the unknown parameters which are given in the vector whenever that vector is a solenoidal vector. So this is also some important. So now we'll take another problem here. Do f bar is equal to r power n into r bar. So now in this problem we'll see what is r and what is r power n. So r power r bar is an unit vector, so which is given by xi bar plus yj bar plus zk bar. So in the problem, in some problems they will give the r bar value, in some problems they will not mention that r bar. So whatever it may be, if it is mentioned or if it is not mentioned, you consider that r bar is equal to xi bar plus yj bar plus zk bar. So from this, If you find out the magnitude of this vector, that magnitude is represented with only r. So small r is equal to magnitude of modulus of r bar, which is given by square root of x square plus y square plus z square. This is the value of that r. R bar is this vector, r is a scalar which gives the magnitude of the given vector, which is given by square root of x square plus y square plus z square. So these are the two important points we have to remember whenever he has given that f bar value in terms of r and r bar. So this is our f bar value. So we have to find out div f bar value. So find div f bar and find n if it is a solenoidal. After finding the divergence of f bar, in order to say that f bar is a solenoidal, then what will be the value of n? We have to find out that n value here. So now, so already we have seen r bar is equal to xi bar plus yj bar plus zk bar, and r is equal to modulus of r bar, that is square root of x square plus y square plus z square. Now remove the square root here. By applying the squaring on both sides, you will get r square is equal to x square plus y square plus z square. Now find out the partial derivatives with respect to x, y, z. We will get, so 2 into r square, derivative of r square is 2r, and r is a function in terms of, this is our r. Once if you observe this r value, this is in terms of x comma y comma z, and that means this r is also a function in terms of x comma y comma z. So once again, first we have to apply the derivative for this main function, and then we have to apply the derivative for the sub function, that is dou r by dou x is equal to 2x. So now we want only dou r by dou x, so send this 2r to this side, 2 gets cancelled here, you will get x by r. And similarly find out dou r by dou y and find out dou r by dou z values here. So now f bar is equal to, this is our vector, r power n into r bar, r power n, r bar replace with its value and remove the brackets. This is our resultant vector. You compare that resultant vector as f1 I bar plus f2 j bar plus f3 k bar. So you will get f1 is equal to r power 1 into x, f2 is equal to r power n into y, f3 is equal to r power n into z. Now find out the partial derivatives here. So dou f bar is equal to dou f1 by dou x plus dou f2 by dou y, dou f2 3 by dou z. Because he asked to find out dou f bar value here. Okay, dou f bar value is given by this partial derivatives, and add that partial derivatives here. So f1, what is our f1? R power n into x. What is our f2? R power n into y. What is our f3? R power n into z. Apply the partial derivatives here. So dou by dou x of r power n into x. First we will see one term here. So r power n is a function in terms of x, y, z. X is also a function in terms of x, y, z. So here we are having product of two functions uv. Apply derivative of uv formula. So you will get this one. And here also you apply the derivative of uv here. So finally you will get these values after removing all the brackets. So now in place of dou r by dou x, dou r by dou y, dou r by dou z. Already in the previous slide we have seen values of dou r by dou x, dou r by dou y, and dou r by dou z. So that is given by x by r. Dou r by dou y is given by y by r. Dou r by dou z is given by z by r. And here we are having r power n. Here we are having r power n, r power n. So totally we are having 3r power n. So now simplify this. We will get our required value for this. So finally you will get this one. You take r power n outside. The remaining one is 3 plus n. So this is our div f bar value. So div f bar is equal to 3 plus n into r power n. Now what is our problem? In order to say that this f bar value, this vector is solenoidal, what will be the value of n? That is our problem. How can you say that vector is solenoidal? Div f bar is equal to 0. So in order to satisfy this condition, in place of n, what is the value we have to substitute? That is our question. So now equate this. So in place of this, so 0 into anything equal to 0. So we have to get 3 plus n is equal to 0. So n is equal to minus 3. So when we replace n with minus 3 here, plus of minus 3, we will get minus 3. So 3 minus 3, 0. 0 into anything equal to 0. So if d bar value is equal to 0, then we can say that bar is solenoidal. This is possible only when n is equal to minus 3. So when we take n is equal to minus 3, the vector, whatever the vector he has given for f bar, that vector becomes a solenoidal vector. This is our problem here. Okay, so these are some examples we have taken under this divergence of a vector point function. So in this video we have discussed about the divergence, how to find out the divergence for the vector point function, and we have taken some problems on the divergence of that particular vector point function. In the next video we will go for curl of a vector point function. That is the last quantity, new concept we are going to discuss under this vector differentiation. Thank you.